Today I'm going to talk to you about Sane Async patterns in JavaScript. A little bit about me. I work at HubSpot, which is out in Cambridge, Massachusetts. We build web-based marketing software. It's a cool place to work. If anyone wants to move out to the East Coast, we're hiring pretty aggressively, so come talk to me afterward if you might be interested. I'm the author of a few books. Can everyone hear me, by the way? Louder? Yeah, close the door, please. My first book was CoffeeScript for Pragprog that came out a few years ago. Then I wrote Async JavaScript, which will be the basis for this talk. It's also from Pragprog. And my current pet project is a book on NPM, the Node Package Manager. So if there are any Node folks here, you might be interested in taking a look at that. You can buy a rough draft now, and you'll get the final version when that's released. So today I'm going to be covering, I'm going to try to convince you that callback arguments are almost never the right solution to your async JavaScript problems. You should be always looking for an alternative pattern. And I'll look at three of those patterns, PubSub, Promises, and AMD. Now this is going to be a fairly high-level talk, so if you already are using PubSub Promises and you feel pretty comfortable with them already, then you probably won't get much out of this talk. But if you haven't gotten into PubSub and Promises, then this is going to change your life. So why are callback arguments bad? Well, a lot of people come to JavaScript and they start seeing a lot of code like this. It's called the pyramid of doom, and it just drives them out of their minds. Because if you're coming from a language like Java or Ruby or Python, you're used to seeing code like this. And it is so much simpler. You just state what you're doing in order, and error handling is simpler. It's just so much more intuitive. On the other hand, in JavaScript, you can't have your code being interrupted by other threads. You know for certain that that state is never going to change between two lines of code. And that is a wonderful blessing. You never have to do this thread sleep loop while you're waiting for something to change, because effectively the runtime is already doing that for you. So as long as you're using async event properly, you're actually saving a lot of trouble. And you guys have probably seen this. This is one of my favorites. Like, the threaded world may seem appealing at times, but it has a lot of its own problems. And you would be seeing another talk right now about how to avoid those problems if you were in one of those languages. So we have this single-threaded language, but we want to use it without writing code that looks like this. And it's not just a problem because it's verbose. It's also a problem because when you have callback arguments, it encourages you to write inflexible APIs like this. Here we have this function that does a very simple thing. We're launching a rocket at a target, and then over time the rocket moves toward that target, and we're drawing it as it moves along, and then it calls this callback when the rocket reaches its target. Well, what if we want to modify this later to issue updates as the rocket moves toward its target? Well, then we'd have to add more arguments to it, maybe have an options hash as well as the callback argument. It would just be pretty unpleasant for everyone involved. And it's fairly simple to use in its current form, but it isn't something that you would want to refactor going forward. So let's look at the first pattern that can help us solve that. PubSub, you've seen this already. If you use jQuery, you use it like this. You say, I have this element. I want to subscribe to click events on this element. The element publishes click events. We subscribe. That's why we call it PubSub. If you're in the Node world, you have a server. You wait for a request. Looks very similar. If you're using Backbone.js or Ember, you wait for a change on a model. Again, it's PubSub. PubSub is an incredibly versatile pattern. It's bread and butter of JavaScript. It's almost certainly like 90% of the time, what you should be looking at using instead of callback arguments. All you have to do is take an object, make it an event emitter, usually by extending some prototype. This is a good library that's an implementation of the Node.js event emitter standard, just runs in the browser, runs anywhere, very lightweight, very simple. And you just inherit it, trigger events on those events. Now it's nice that Node has a standard way of doing this, the event emitter class, so pretty much every Node library uses that. Unfortunately, in the browser, you have a number of subtly different APIs. So if we use this for our previous example, we instead have a rocket object, and when the rocket reaches its target, it's going to emit this complete event. And each step along the way, it emits a moved event. And heck, we emit a launched event when we fire it, because maybe someone else has this rocket object other than the code that fired it. And it's just so easy to add more and more events as we want them. There's no cost to doing it. And it's just as easy for the caller as well. In fact, this code is a lot more readable because you have the word complete there. It tells you what that callback is for. The code wasn't self-explanatory before when you just said launch rocket and here's a function. Really, the only drawback to PubSub is that there's no standard for it. .on can mean different things, or maybe it's .listen in some libraries. In jQuery, you can use colon to namespace events, and Backbone, you can use spaces to separate event names. There are those subtle differences. There's a nice library called Lucid.js that you can use to wrap around all these different kinds of event emitters to just have them map to an event emitter with a standard API. So this can be really nice if you're using a variety of libraries with different styles of event emitters and you just want to unify them. You can pipe events from, say, DOM objects and jQuery elements and Backbone models all onto a single event emitter that just emits those events in the standard way. So PubSub is pretty awesome most of the time. But promises are something I'm really passionate about. How many people here are already using promises? That is wonderful. That is, I suspect, many more than were using them about a year ago, because jQuery just introduced them in jQuery 1.5 beginning of 2012, and that just completely changed the JavaScript landscape. I mean, Dojo had them before, but let's face it, jQuery is a lot more popular. So what is a promise? A promise represents the eventual value returned from the single completion of an operation, is how it's defined in the CommonJS Promises A spec. That's a nice intuitive way of thinking about it. A function just returns this value, and the actual value might not exist yet because it's an async function, but when you need that value, you can get it from the promise by binding listener. A little more concretely, an object will start out in this pending state, and then it goes into either a resolved or rejected state. And every promise has this in common. So you can think of it as representing the success or failure of an operation, usually something async, like an AJAX call. And when it moves into the resolved state or the rejected state, it calls all the listeners that are bound for listening to the move into that state. So here's how it's done in jQuery. When you make an AJAX call, the value returned by that AJAX function as of jQuery 1.5 and above is a promise. And when you pass a listener to the done function on that promise, then you get something that's going to be called when that AJAX call succeeds. And when you pass a listener to the fail function, you're getting something that's going to be called when it fails. Pretty simple. and you can check the state at any time. And what's really nice is that you can stack an unlimited number of listeners onto this object. You can also add more listeners even after the promise has resolved or been rejected. So if you were, for instance, to bind a function to fetching data.done after the AJAX call was already completed, that function would be called immediately. And it gets all the same information that you would get by passing success or failure handlers directly to the AJAX function. So it's just a very flexible syntactic sugar, essentially. But there's so much more to it. We'll get into that in a moment. Oh yeah, and then is just a shorthand for calling .done huzzah in this case and .fail alas. You can also use this for animations in jQuery. If you call the promise method on a jQuery object when it has an animation or stack of animations that it's in the process of doing, a promise will be returned that gets resolved once all of those animations are completed. And this can be really nice if you have multiple elements that are animated because the promise that's returned from those elements is a promise that will be resolved when all of the animations on that entire set of elements has completed. And to be clear, this promise resolves when all the animations up to when .promise was called have completed. So if you started some more animations after creating that promise, those animations would have no effect on that promise. So you could have different promises at different stages of the animation of various elements. There was a blog post a couple of days ago that got pretty big, had a pretty big impact. You may have seen it on Twitter. Pretty in-depth technical look at promises and how to think of them. Highly recommend reading this article. This is another great way of thinking about promises, that a promise contains a value and you use a function like then or done or fail to unwrap that value. So in jQuery, there's this thing called a deferred, and a deferred is how you create a promise. You just use that constructor, and then you call resolve on that object to invoke all the listeners on the done method to say this promise has succeeded, move it into the resolved state. Or you call reject to move it into the rejected state. And you call .promise on that deferred to create essentially a read-only copy. The only difference between the deferred and the promise is that the promise doesn't have those reject and resolve methods on it. So here's an example of a very simple plugin you might write. If you weren't using promises, you're just making an AJAX request for some content, using it to create some HTML in this element, and then you call some callback. Or if the AJAX request fails, you create an error message and then call a different callback. So this isn't too bad, but with promises, you can ditch a lot of that code. You just use the promise returned by the AJAX call and bind what you're doing onto its resolve and reject handlers. And then you return that promise from your plugin. And it's just as easy for your caller as the other code was, because either way, they're just attaching callbacks. So essentially, it's reducing the duplication in your code. You don't have to manually stack callbacks because promises takes care of this callback stacking for you. So that's a great use case for promises. Another great use case for promises is when you have multiple asynchronous actions that you want to coordinate. jQuery gives you this when function, where when you pass in a series of promises, it returns another promise that resolves when all of those promises resolve. So in this case, we're fetching something and we're doing an animation. and after both the fetch and the animation have succeeded, this promise returned by when resolves. Now, if any of the promises that are passed to that when function are rejected, the promise returned by when is rejected. So that can simplify error handling greatly. If you need to make a series of AJAX calls in parallel, for instance, you only need to have one error handler for when any of them fails. But here's the real magic of promises. It's when you get into this pipe function we'll see in a moment. Let's say, and this is a little ridiculous, but let's say that you're fetching a password from the server, and then once you have that password, you're logging in with that password. So those are both asynchronous things. You need to do those in that order. And then after you made this post successfully and you're logged in, you have this other promise. But ideally, because you don't want to get into another pyramid of doom situation, you want to attach handlers to this logging in promise from outside of the fetching password handler. And this looks impossible because that logging in promise doesn't even exist until you've initiated that AJAX call. But there's this amazing function called pipe. When you return, pipe looks exactly like then, except that when you return a promise from a handler in pipe, pipe returns a promise that is resolved or rejected when that promise is resolved or rejected. So in essence, pipe allows us to see into the future. This logging in promise that's returned by fetching password.pipe is going to be resolved or rejected precisely when this promise returned by post is resolved or rejected. So then we can just say, okay, once we've logged in, then there's our handler. This also makes error handling much simpler because the error handler on that promise will be called when either that first fetching promise is rejected or the login promise is rejected. So that same pyramid of doom code that I showed you from before, if you assume that all those functions return promises, you could write it like this. It's completely flat, and you can still attach as many handlers as you like to any step of this complex process. We can also implement the rocket example using promises. So here rather than having a rocket class like with PubSub, we just have this function return a rocket promise because it's a one-time task, which is really when a promise is the appropriate solution. So you see that when the rocket reaches its target, this promise is resolved. In addition, I'm using the deferred notify function, which is something that jQuery has, where you can get progress updates as your promise moves along. It's an optional thing. The typical convention is just to indicate the percentage complete as a callback argument for that. So that's being done here. So a recurring theme here is that there aren't a lot of standards in JavaScript because we're all fairly new to this. jQuery has its own implementation of promises, which is what I've been showing you. There's this CommonJS promises A spec, which uses a different vocabulary. There's fulfilled instead of resolved. It gets a little confusing if you're using both promises implementations in the same project. And a year ago, when I would talk about promises, I would say, okay, there's jQuery and there's promises A, and those were the two options. Now, if you go onto the CommonJS wiki, you'll see 4 or 5 promises proposals. Promises A, promises B, promises C. They all have slightly different functionality, slightly different features. And there are different implementations of these all over the place. So it's unfortunate that the environment is this fractured. Obviously, if you're using a jQuery-heavy project, you're just going to want to use jQuery promises. If you're using a Node project, you'll probably want to use crisqual/q on GitHub. But it's unfortunate that there isn't just one standard and one standard vocabulary we can use when talking about promises. The mental model for them all is the same. It's just they call functions different things, really. And the other drawback to promises is you only get these amazing benefits of promises when you're using libraries that return promises. If you're using libraries that take callback arguments, then you're going to have to wrap around them, essentially, by passing callback arguments that resolve or reject promises. And that drains away a lot of the joy of promises, this syntactic sugar that simplifies things so much. It still may be worthwhile if you need to do things like piping or waiting for multiple async events to resolve, but it's not ideal. So I'd like to touch on AMD briefly, just because it fills in a gap that neither PubSub or promises is really perfectly suited to, which is loading dependencies. AMD is the asynchronous module definition spec. It's a common JS thing. Each module states which modules it depends on. And that's about it. It's really a pretty simple concept. You can use it to load dependencies as they're needed, often asynchronously. Another nice advantage of it is that you can easily redefine things using AMD. So for instance, injecting different versions of dependencies for tests. Or at HubSpot, we do a lot of feature gating where we're developing a new version of a feature. We want to roll it out to just a beta group of customers. So using AMD, it's fairly simple to say, okay, if this customer is in the beta, then define this version of the dependency, and otherwise define this version. So this is what AMD looks like. You just have a define function where you give the name of your module, and then you have an array of the names of all the modules that you want to load. And then only after those modules are loaded, your module's factory function, it's called, gets loaded, and it's passed those dependencies as arguments. So it's fairly simple. If you're used to just seeing modules without any wrapping around them, or just an IIFE, it's a little unpleasant to jump into this world where suddenly every module has this list of its dependencies at the top of the file. And that's probably the main reason AMD hasn't caught on. So, I mean, it's caught on in some circles, but it's certainly not ubiquitous. But you get huge benefits once you've made this investment. So AMD is itself a standard, but it's not an ubiquitous standard. So as with everything in this talk, unfortunately, it's not something that all JavaScripters are on board with. There's a lot of upfront work involved in implementing this boilerplate because you need to, for every module in your application, state every module that it depends on. If you have 100 modules, that's a lot of work. AMD doesn't do semantic versioning. So for instance, if you have a module that depends on jQuery 1.9 or above and another module that depends on jQuery 1.8 or above, there's no way to say, okay, I have jQuery 1.9, this fulfills both of these dependencies. You're limited to just giving the names of the modules that your module depends on, not version numbers. The require.js tool is pretty heavyweight. There's a pretty steep learning curve to it. It's incredibly versatile. You can have it, you can tell require.js, okay, I have all these AMD modules. I want you to bundle these things together and asynchronously load these things. And AMD says okay, but you have to tell it what to do first, and that takes some work. Probably the main alternative to AMD and Require.js right now is a library called Browserify that's aimed at just making browser-side modules as similar to Node-style modules as possible. You just say require and then a relative file path, or the file can be in a Node modules directory. And it's kind of magical. If you're familiar with Node and NPM, this is an amazing thing. It's really only intended for bundling things together. It's a little trickier to get it to asynchronously load modules, which is something that, of course, AMD and Require.js is very strong for. But it's an alternative well worth considering, especially since it supports semantic versioning. So as I mentioned before, that can simplify a lot of scenarios. So I hope that I've convinced you that callback arguments usually aren't the best solution to a problem. It's usually PubSub, sometimes promises, or something like AMD. There's always a better solution out there. Just using callback arguments is a recipe for nesting callback arguments, and that's a recipe for unreadable, unmaintainable code. So at this point, I'd like to thank you. And can I get some questions, please? Questions? Yes?
Sure. Can you speak to the about the overheads of using promises, like adding to your code base?
The question is about the overhead of promises. You mean like just performance-wise?
Sure.
I'd say negligible. Yeah, it's a very simple wrapper. I can't see any situation where that would have a large performance impact. Sorry, what's that? Yeah, you have to load the library, but I think a promises library is so lightweight that we're probably talking a kilobyte. No, I really wouldn't worry about that kind of impact on your application. If you have any GIFs on your page, removing one of those will have more of an impact. Yes?
Give an example of when you'd use AMD to do like an A/B test. You're saying like some customers in the data and some in the control group. You said Require.js doesn't support semantic versioning, so I'm wondering how you do that there.
Right, so let's go back to that slide. So what you can do is simply, around this, say, if my beta flag, then define my module like this, and then else, like just put an if up here, put an else down there, and you're defining my module either way, but you're defining it with a different function, maybe different dependencies. Yeah, I mean, that's the way I'd recommend doing it. I mean, it would be possible. If you're using AMD, you can define the file. The trouble is at runtime determining which definition you want to use. I don't know if Require.js has a way of doing that. Yeah.
And then basically change the config depending on your text.
Right. So if you were creating two different bundles and serving different bundles to different customers, then you could do it through different Require.js configuration files. Yes?
I had a question regarding the slide. You had the point function.
Mm-hmm.
I was curious because it looked like that. So if it digging and jQuery actually kept repeating and just replacing
I don't believe that happened. I think that was proposed, but
It did. The 1.8 or 1.8 is deprecated. So now you're using that instead of pipe.
oh,
Yeah.
wow. That I apologize for the deprecated slide. It's interesting. I followed that discussion, but I thought it was a no-go. All right, so you can just use then instead of pipe, which is great because that's the common JS way of doing things. Thank you. Yes?
Regarding AMD, if you want to serve that collection, you would probably compile all your files into one single bundle. So if you need to do pre-processing, what's the advantage of using AMD compared to other solutions such as Clojure or things like that that do that already?
Sorry, how does Clojure compare? That's-
I'm asking, what's the advantage of using dynamic Clojure or dynamic migrators such as AMD when in production most likely you just want to serve one JavaScript file, so
Oh.
you have to go through a compiling process.
Right, so even if you aren't loading dependencies asynchronously by fetching them from the server, a really nice thing about AMD, which I should have mentioned, is that you can then bundle your JavaScript files in any order, and they'll just be sorted out correctly at runtime. If you're using something else to minify your files, you have to specify somewhere, okay, here's the order in which these things need to be concatenated, and then you have to make sure that that order is always right as you're changing things. So that's a major headache that AMD helps you avoid.
Right, but my question was compared to the Clojure library, for example, what's the advantage of using AMD?
Right. I don't believe Clojure has a way for modules to express their dependencies, does it? Does- Sorry, I'm not familiar with Clojure.
I think so Clojure you have to run your compilation, while if you're using Wire.js, you can do it dynamically, go for it, and then run RJS. Which you can actually run it so it will. So then you just have to do it.
I'd add to that, another thing that you can do with AMD is specify like different bundles of modules so that you can say, have a common set of files that you want to deliver to all of your clients and then have asynchronous loading happen for other modules depending on what page of the site they're on. Allows you to have a much smaller initial load.
Mhm. Yeah, AMD is wonderful for mixing concatenation and asynchronous loading because you can specify that in a configuration file, which things you want to treat which way. Were there other questions? All right, thank you very much.